Hello, welcome to Econometrics Melody. In this tutorial, we'll deal with the two-way contour and two-way contour line plot types, as well as manipulate the legends. So let us prepare our data set. This time we're going to have a pretty short data set, and we're going to have three variables, x, y, and z. X, y may be length and breadth, and the z variable maybe it's a height or depth. And let us see the first plot type. It is a contour plot, and we specify the two-way contour and the variables, three variables, and the result is this. So we get the color bands. So these color bands, maybe they represent the depth or maybe the height, or according to the nature or according to their meaning. So it's, for example, if x represents the breadth and y represents the width, for this breadth and for this width, we have this level of height between red color between 150 to 200. So this is a very useful graph. And now let us manipulate the zlabel. We are going to label this according to this rule. So we will have two labels between 0 to 200 at the interval of 100. So we'll have two labels, and this is the depth if we want to call the z variable depth. So from 0 to 100 and 100 to 200. And we can manipulate again. Let us see another variation from 0 to 200 at the interval of 60. We'll have three labels. So 1, 2, 3 color bands and three labels impact from 60, 120, 180, and above 180, this portion. And the other one from 0 to 200 at the interval of 40, we will have 5 points or 5 color bands. 5, and this is clear at the interval of 40. And let us combine them together and see it for ourselves. Now let us display the grids. So while creating the data, we must, or while filling or collecting the data, we must, this will help us. The understanding of this grid, the understanding of grid will help us. So this is the grid of 21 into 21. So all the interactions of y and x, all these cross Cartesian product, we should have the data of these Cartesian products. And if we don't have the data, we can use the interpolation options as well. So I have manually plotted or enforced the created y and x in such a way that their Cartesian product was possible. So 21 into 21, this is the grid of 21 into 21, and we can use the options in order to explore the results. So ccuts, this is the counter cuts. We can specify the number of counter cuts labels. This will create this level of color bands and min max, and these are the counter rules and starting color, ending color, and we can specify our custom colors as well by this option ccolors. And interpolation in case of missing values of these grids, some points at the grids, we can use this interpolation. And the two-way options are the familiar options that we have been using since now. Now let us see the options ccolors, label, and zlabel. They are they provide a similar result. First of all, let us explore ccolors. So we are going to use 5, so 200 at the interval of 40 up to from 0 to 200. So the 5 color bands are evident. So these are the counter plots. And we can get a similar result by specifying label. If we specify label 5, we'll get the 5 color bands, and the color are comparatively very dark this time, but the 5 labels. And if we specify zlabel, we are also going to get the z axis. This is the representation of the z axis that is going to labels at 5 points or following this rule. And now let us combine them together. We should not see any difference except the colors. So the 5 bands, we get the 5 bands. Their labeling are slightly different. So label 5, it creates 5 colors, but their labels are different. Counter colors, it creates again the 5 colors, and their labeling, they follow a different rule. It's a 40 to 80, 600. This is similar to the third one, and they have, all of them have the 5 color bands. And now let us see what happens if we use the label and zlabel options together. What happens? The label will color here label 7 color bands, and z-axis will be labeled following this rule. So 1 2 3 4 5 unique points, and then 7 different colors. The interpretation is similar. For this length and for this breadth, we have this level of height equal to the color, and we can see it from this spectrum of the color and interpret accordingly. Now let us change the colors. So by specifying, first of all, let us take a basis graph for comparison, and then we are going to use the starting color to be pink and ending color to be yellow. So in this legend or z-axis label, we see the starting color is pink and the end color is yellow, and if we combine it together, we should see the differences. So the default graph and the manipulation of color. So this is our custom color, pink, yellow. Similarly, let us use another option called the ccolors, and what happens. So here zlabel angle is 90°, and let us use the custom colors now. 5 bands of color, 1 2 3 4 5 bands of colors, and we have specified the custom colors pink, black, red, cyan, and mint. So it should be pink, black, red, cyan, and mint. And let's combine them together and see it for ourselves what are the differences. So this is the custom or the default one, and we have manipulated the colors by specifying C color, pink, black, red, cyan, and mint. Now let us off the legend by specifying C legend. So counter legend should be off. We won't get this legend for this graph. And let us see it and let us compare it again. So one with the legend and one without the legend. And for reinforcement of understanding, let us create some hypothetical x1, y1, and z1 variable, and let us create the vertical bars of same colors. Along with this scatter is going to manipulate this scatter points, and these are the color bands, right? Vertical color band. And then we can also create some other patterns, this kind of patterns, and we can get it artistic as possible. And this may not be useful for our analysis, but this is for the sake of understanding. And we can also choose the custom colors here, yellow, teal, black, and green, and let's create some sort of pattern. So this is the pattern, and if we combine it together, so this creating pattern may not be the purpose of this counter plot type, but in order to make our journey exciting, we are trying this. And let us drop them all and quickly move to other plot type, two-way counter line, and this simply creates the counter lines, does not fill the area with any colors. And if you want colors, we can specify these color lines and we'll get different colors, and the legend for that colors, explanation of the color, and let us combine them together. The interpretations are similar to the previous one. And now let us again provide the custom colors if these are the different default colors by specifying color lines. And if we are not happy with these colors, we can specify our custom colors by C color options, red, black, yellow, pink, and green, and let us combine them together again. Now the other option is counter line width. So by its name, it should be evident that we're going to manipulate its width, and let us specify the width as well as the custom color. This time, if you look at the counter line width, this has increased, and along with the custom color, now let us change these colors by red, black, yellow, pink, and green. Red, black, yellow, pink, and green. So let us combine them together and see it for ourselves. And these are the common options that we have for the counter line that is similar with the counter plots, and they hold the same meaning. So these are the options which are very evident by now. And let us quickly move to the other plot type, or before we leave, let us manipulate the legend. So this is the legend. We can manipulate the legend as well, and let us see another example for this. So this is the basis graph. We have specified 3 different or 4 different plot types. So for this we will get at least 3 or 4 different legends. So these are the legends, And we can, if we are not happy with its label, we can manipulate the label name by specifying. So this is first label, second label, third label, and we can call the label and change its label name. That is what we are going to do here. We are going to call the label 1 cyan, label 2 orange, and label 3 black, and this should be evident by the display of this graph. Sand, orange, and black, these are their respective colors, and we can again manipulate its order. If we want to display 3 1 2, this is 3 black, sand, and orange, we will get this black, sand, and orange. And again, if we don't want the kind of display over here, so if we want to arrange it in a single row, we can do that by specifying row 1. Now they are in their single row, and if we want any two of them to be displayed, we can call them, just simply order them. So order second and third, only the second and third will be ordered and displayed. So this was the second and this was the third. And similarly, we can arrange them in a single column as well by specifying column 1. So one column, so we get the legend in a single column. And if we want to change its position, we are going to display this legend in the 3 o'clock position to the extreme right, at the middle extreme right, and we are going to stack it as well. So this color and the label will be stacked. So in this format, this is the 3 o'clock position of our hand of a clock, and they are stacked, color, band, and label. And if we want to display or put this legend at the 12 o'clock position at the topmost place, and we are specifying row 1, they are at row 1. And if we want to place this legend inside this plot region, we will have to specify ring 0 for this legend, and this will be somewhere here, and because this is either ring 0 and position is also a 0 o'clock position, so just at the center of the clock. And if we want to completely switch up the legend, we can specify the option for legend off, and we will not see this legend. And if we want to arrange, now let us combine them together, and here I have manipulated this on the option called holes, and which will be evident by this graph. So while combining, this block will be empty, second block, 4th, 6th, 8th, 10th, 12th, 14th, 16th, and 18th block will be empty. So these are the holes that we have created, the block number, 2nd, 4th, 6th, 8th, 10th, and so on. This is due to this option for holes. Now let us drop them all, and before we end, this is a short program, and we can run this program. I'm going to run a program called ECONOMETRICS EM, and then these are some of the commands that I have written, and this is related with the plot types or the diagrams. So like, let's say scatter I and scatter I, and once I have given the name of the program age em. Now let me run anything, age for example as 2way, and then scatter I, let's say 120, 120 again, and at 3 o'clock position I want to display thank you, and let me write thank you. Fine, we'll get this graph, and I want to close this graph, or even if I clean the memory, clear the memory, and if I run that program that I have written, that is the R class program, and the name of the program was EM, and the result will be displayed. It's a time to thank you all for your precious time. Thank you very much for your time. Thank you very much, Econometrics Melody.